You've probably heard all the hype, right? 2024 is supposed to be the year of agents, the moment AI assistants finally become our digital employees, handling everything for us. But what if that's off? Like by a factor of 10. Today, we're diving into a huge reality check from one of the most brilliant minds in AI, Andrej Karpathy. So here's how we're going to break this down. We'll start with his big prediction, then get into this really cool analogy he has for today's AI. After that, we'll peek under the hood at how they actually think, figure out what's holding them back, and then look at his plan for building a real cognitive core. And finally, we'll tackle the big one. What does this all mean for us? All right, first up is the core idea that pretty much flips the script on everything you've been hearing. Karpathy's telling us to zoom way out from all the short-term hype and think on a much, much bigger timeline. And he puts it just that bluntly. This is his direct response to what he calls all the overprediction in the industry. This isn't just a small tweak, it's a totally different way of looking at how fast AI is actually moving. So what's the real difference here? Well, it's the massive gap between a flashy demo that works once and a truly reliable, trustworthy tool that you could actually depend on day to day. And according to Karpathy, that gap is just huge. So why a full decade? I mean, that sounds like a long time, right? Well, the simple answer is that today's agents just don't work well enough. To be a reliable intern, never mind a full-on employee, an AI needs a ton of skills that it just plain doesn't have right now. And I mean, just look at this list. This lays out the problems perfectly. They can't continuously learn. You can't just teach them something and expect them to remember it tomorrow. They're not truly multimodal, so they get confused trying to juggle text, images, and sound all at once. They're clumsy when they try to use a basic computer, and as Karpathy says, they're just cognitively lacking. The bottom line, they're not ready for the job. Not yet. Okay, this next part is, I think, the most fascinating piece of his whole argument. It's an analogy he uses to explain why these models are so limited, and it really gets to the heart of how we're building them. He makes this incredible distinction. You can either build intelligence like an animal, through millions of years of evolution and direct interaction with the messy, real world, or you can summon it like a ghost by getting it to just imitate the massive archive of human text and data on the internet. And you guessed it, we're doing the ghost thing. And this is just such a crucial point. Our current method doesn't create a being that learns and adapts from the ground up. It creates this digital echo. It's incredibly good at mimicking human patterns it's seen before, but it doesn't really learn from first principles. It's an echo, not an original voice. He even has this hilarious line where he calls pre-training our crappy evolution. And it makes sense, right? It's our messy brute force shortcut. Instead of the slow, careful process of biological evolution, we just dump the entire internet into a model and hope for the best. It gets us to a starting line, but it's a fundamentally different and probably shallower way of getting there. So, how does this whole ghost nature actually work on a technical level? Well, it really all comes down to the very strange way these models remember things. You can basically think of a large language model as having two kinds of memory. You've got the model weights, which is its long-term memory. That's all the knowledge it soaked up from the internet during training. Then you have the context window, which is its working memory, the stuff you're talking to it about right now. And the scale of that long-term memory is just mind-boggling. A model like Llama 3 is trained on something like 15 trillion tokens of data. That's more text than any person could read in 1,000 lifetimes. But, and here's the really important part, all of that information gets squeezed down into a relatively small space. This is exactly why Karpathy calls its long-term memory a hazy recollection. Think about it. It's like remembering the general idea of thousands of books you skimmed years ago versus having one single page open right in front of you. The stuff in the context window is crystal clear, but all that knowledge in its weights is super fuzzy. So once you understand that weird memory structure, you can start to see the exact technical problems that make these agents fail at complicated tasks. Karpathy uses this incredible phrase to talk about reinforcement learning, or RL, which is one of the main ways we try to teach models new things. It sounds really powerful, but he says it's like trying to drink a whole lake through a tiny coffee stirrer. And here's why it's so ridiculously inefficient. The model will try, say, hundreds of different ways to solve a problem. A couple of those attempts will work, maybe just by pure luck. The model then gets a single, hey, good job signal. The big problem? It reinforces every single step it took on that successful path, including all the dumb mistakes and wrong turns it made along the way. It's just an incredibly noisy and messy way to learn anything. And then there's this other huge problem called model collapse. This is what happens when models start training on their own AI-generated stuff. So instead of learning from the rich, messy, diverse data that humans create, they start learning from their own limited, kind of boring outputs. They just become bland and repetitive. And here is a perfect everyday example of this. You can try this yourself. Go ask a chatbot to tell you a joke. You'll probably get one of these. Ask it a few more times, and you'll quickly see it has this tiny, collapsed set of jokes it just cycles through. It's a really simple way to see a model that's lost its diversity and is just echoing itself. So after laying out all of these problems, Karpathy gives us this really compelling vision for what we should do next. And it's not just about throwing more data at the problem. It's about building a whole different kind of intelligence. The goal for the next decade, he says, should be to build what he calls the cognitive core. The big idea is to stop relying on that fuzzy, flawed memorization of facts from the internet, and instead to isolate and build the pure underlying engine of intelligence itself, the raw algorithms for reasoning, planning, and actually solving problems. Okay, so what does this all mean for the really big picture? You know, the dream of artificial general intelligence or some kind of superintelligence explosion that changes the entire world overnight. Well, Karpathy argues that AI isn't some sudden, shocking revolution. It's actually just the latest and most powerful step in a very long, continuous trend of automation. From compilers in the 50s that automated coding to search engines that automated finding information, we've been on this exact path for decades. LLMs are just the next step on that same path. In his view, we're already in the middle of a slow-motion intelligence explosion. We're not going to see this sudden, sharp spike in economic growth because of AI. Instead, AI is what will allow us to continue the powerful exponential curve of progress we've been riding for centuries. It's not starting a new fire, it's just adding a massive log to the one that's already burning. And that leaves us with one last, really provocative thought. If the danger isn't some sudden Skynet-style takeover, then what is it? Well, maybe the real risk is something a lot more subtle. A slow, gradual loss of control and understanding, as our world becomes more and more run by these incredibly complex autonomous systems that fewer and fewer people actually comprehend.